Hello friends, till now under the video series on geography, I made videos on geomorphology, climatology and climatic regions. In this video I'll begin with oceanography. Under oceanography, the first concept is ocean relief or ocean relief features. Before trying to understand ocean relief features, we need to know a little about the formation of oceans, because various tectonic forces that led to the formation of oceans are the primary reason behind the formation of various ocean relief features as well. And to understand the formation of oceans, we need to know a little about the divergent plate boundary. We know that there are convectional cells in the Earth's mantle. Convectional cells are nothing but cyclic movements of magma in the mantle portion of the Earth's interior. This particular movement of magma is the primary force behind the movement of various Earth's crustal plates. And when we have a specific movement, as we can see in this particular figure, where two convectional cells converge, giving rise to a rising limbs, gives rise to a divergent plate boundary. In the reverse case, when two convectional cells converge and when we have falling limbs, in such a case we will have a convergent boundary. But here we can see two rising limbs converge, giving rise to a divergent plate boundary. And the movement of magma drags the plates away from each other, giving rise to various landforms. The first step in convergence is upwarping of the Earth's crust. Upwarping is nothing but the deformation of the Earth's crust because of the diverging plates and the pressure acting on the Earth's crust region because of the rising limbs of the convectional cells. Here a series of faults are established, and the most common one is the normal fault. We know that there are three important kinds of faults. The first one is normal fault, where a block of earth slides downwards. This particular movement is called as subsidence. In the other case, we have reverse fault, where a block of earth moves upwards or slides upwards, and this particular movement is called as upliftment. And in the third case, we have transform or transcurrent fault, where two blocks of earth slide horizontally, grinding against each other. Here there is no vertical movement, there is only horizontal movement. In such a fault is called as transform or transcurrent fault. So in the upwarping process, that is UPWARPING, in the upwarping process we have deformation of the Earth's crust with establishment of a series of faults, and the normal fault is the most dominant one. Following the upwarping process, we have formation of a rift valley with the further divergence of plates. We can see further divergence of plates creates a normal fault, where a block of earth slides downwards, creating a graben. So the subsided block is called as graben, and the blocks which lie at greater elevations than the graben are called as horsts, HORSTS, horsts. So we have graben which has subsided, and horsts which are at a higher elevation. For example, we have African Rift Valley, which is at this particular stage. Once African Rift Valley's crustal region diverges further, then we will have formation of a linear sea, as we can see in the other figure. For example, Red Sea is at this stage, and before the Red Sea became a linear sea, it was a rift valley, but now it is a linear sea. So we have African Rift Valley, which is at this particular stage, that is stage 2, and once after a few thousand years, this particular Rift Valley gets converted into a linear sea. So it will move to stage 3, and the Red Sea, which is now a linear sea, can become a mighty ocean. So we can see the divergence is continuing because of the convectional cells. At a particular point of time, due to divergence, the Earth's crust or the continental plates move away from each other, and they go under the influence of different convectional cells than the convectional cells that act below the ocean surface. So we have convectional cells here which are in this particular path. So here these are the convectional cells. If you see the continental crust has moved away from the influence of these convectional cells, and now they are under the influence of a different kind of convectional cells on either side. And this particular movement of the convectional cells, we know that the falling limbs are associated with the convergence of plates. So we have the ocean floor which is spreading like in the linear sea, and this spreading happens for a very long time, and after a period of time the continental crust and the oceanic crust start converging, and this convergence leads to subsidence of oceanic plate, which is denser. So the oceanic plate subsides, giving rise to a trench near the convergent boundary. So I've already discussed about various convergence and types of convergence in the previous videos. So this is how a mighty ocean is formed. The mighty ocean is a resultant of diverging oceanic plates along with the establishment of various other oceanic features like the mid-oceanic ridge. Along with that, we have seafloor spreading, where the seafloor starts spreading because of various tectonic activities. There is constant outpouring of magma from this vent here, which is between two mountain ridges, which is called as mid-oceanic ridge. So here we can see various relief features are formed because of this particular process of ocean building. So there are important features like mid-oceanic ridges, then we have trenches. Along with that, we have various features like continental slope, shelf, etc. So all these are slowly formed with the formation of oceans. Now let us look at various ocean relief features. There are minor ones and major ones. The major ones include continental shelf, slope and rise, and then we have the deep sea plain, which is also called as abyssal plain. And the minor features include abyssal hills like seamounts and guyards, and we have mid-oceanic ridges, and then we have trenches at the converging boundary, and there are various other features like canyons and atolls, coral reefs, etc. So we can see here the picture clearly indicates the ocean relief features, and we have seen that this is the diverging plate boundary here, where we have a volcanic vent where there is constant outpouring of basaltic magma, and this magma spreads, giving rise to seafloor spreading. And then we have a convergent boundary where we have trenching. Here we have trenching. The trenches are formed because of the convergence between oceanic plate and the continental plate. And along with these minor features, there are major features like continental slope, where the gradient of the slope is quite low. The continental slope is a part of continental plate, and then we have continental shelf. This is continental shelf, and then we have continental rise, which has greater slope, and hence it is very steep. This is also a part of continental plate, and then we have continental rise. Continental rise is less steeper compared to the continental slope, but it has higher slope compared to the continental shelf. And this continental rise is a part of oceanic plate, and it is not a part of continental plate. And then we have abyssal plain, or the deep sea plain, which is formed due to deposition of various terrigenous deposits. We know that various deposits are brought down by rivers and glaciers, and most of the deposits settle on the continental shelf, and when they reach the steeper continental slope, they slide downwards to the ocean bottom, giving rise to a clayey deposits on the ocean floor, giving rise to a flat featureless abyssal plain. And we know that this particular region is because of spreading of the seafloor. And we have volcanic mountains. In my previous videos, I've explained about hotspot volcanism, and there are various other volcanic activities which are happening in the ocean, at the ocean surface, and this volcanism gives rise to various volcanic islands. And those volcanic mountains which doesn't reach the surface are called as seamounts, and the volcanic mountains which have a flat top are called as guyards. All these are part of abyssal hills. Now let us look in detail about each ocean relief. The most important one is the continental shelf. Most of the human activity is confined to the continental shelf. Here the gradient is less than 1 degree, so this is how flat this particular region is, with a very less steepness. And most of the deposits brought down by rivers and glaciers are deposited on the continental shelf region. And the continental shelves are formed mainly because of subsidence of continents or rise in sea level. And we know that the continental shelf is a part of oceanic plate. There are various continents based on the kind of deposits they acquire. For example, we have glaciated shelf like in the Greenland, and the shelves over there are formed because of the deposits brought down by the glaciated region. And then we have coral reef shelf, like we have the Great Barrier Reef to the northwest of Australia, which is an example for coral reef shelf, where the shelves are occupied by coral reefs. And then we have deltaic shelves like the shelf of Nile River. Here the shelf is formed mainly because of the deposits brought down by the Nile River. And then we have shelf with dendritic valleys. We can see there are various canyons along the shelf region, and this gives rise to a tree-like branching canyons, which is called as dendritic valleys. The best example is Hudson River, which is near New York City. And then there are shelves along young mountain ranges. We know that, for example, we have Hawaiian Islands, which are mainly formed because of hotspot volcanism, and the shelves that establishes around these volcanic islands are called as mountains along young mountain ranges, or shelves along young mountain ranges. So in this figure we can see various shelf types. We have Greenland shelf, and then we have Icelandic shelf, which is a part of divergent plate boundary. This is the only shelf region or island region which is very conspicuous over a divergent plate boundary. And then we have coral reef shelf, like in the northwestern Australia. We have Great Barrier Reef occupying the shelf region, and then we have Nile Delta shelf, along with that shelf with Dendritic Valley at the mouth of Hudson River, and then shelf with young mountain regions. For example, we have Hawaiian hotspot volcanic islands, where there are various islands in this particular chain, and we have shelves which are established due to this process. They are called as shelves along young mountain ranges. Coming to the depth, they are not so deep. The depth varies between 30 to 600 meters, and the width varies from region to region, with average width being about 70 to 80 kilometers. And continental shelves are very not so wide or totally absent in certain regions, especially near the convergent boundaries where there is formation of trenches. For example, we have the coastline of Chile and coastline of Japan and various islands like Sumatra, where the continental shelf might be totally absent or it can be of very less width. Whereas on the other hand, we have Siberian shelf. Along with that, we have Grand Banks, which all have a very wide shelves. For example, the Grand Bank region have shelves around with a width of 200 to 300 miles, whereas the Siberian shelf has widths varying from 500 to 1000 kilometers. Coming to the importance of continental shelves, most of the marine food is obtained from the shelf region. We know that shelves are very shallow. As a result, they provide good breeding grounds for fishes and various other microscopic organisms, where both sunlight and nutrients are available at a very less depth. As a result, a lot of phytoplankton grow, and due to which there is good fishing grounds. And most of the important fishing grounds like Grand Banks region, along with that we have fishing off Japan coast. All these are good fishing grounds because of extensive continental shelves. And most of the economic minerals like polymetallic nodules can be obtained by continental shelves. We know that the depth is quite low compared to the other oceanic regions. For example, we have continental rice, which is at a depth of 3000 to 6000 kilometers, and we have abyssal plain, which is much deeper. Its depth might be about 6 to 10 kilometers. So at this depth, even if there are good amount of minerals, still the extraction is very tough process, and there is no technology presently available to extract these minerals. But when it comes to continental shelf, its depth is quite low. As a result, extracting minerals from continental shelf is quite easier. And we know that on the Earth's surface, the resources are fast depleting. As a result, there is a reason for every country to go and explore in the various oceanic regions, and the continental shelves offer the best places because of various metallic minerals like polymetallic nodules, which are nothing but manganese nodules. They have concentric layers of iron and manganese hydroxides. Along with that, there are various minerals which are found in polymetallic nodules like gold, copper, and various precious metals can be obtained from polymetallic nodules. Along with that, we have various petroleum reserves, the most important ones. For example, we have Persian Gulf and the surrounding regions. Along with that, there is a sea called as Barents Sea to the northeast of Russia, and this particular sea is said to have greatest reserves of oil, and hence Russia has started exploring this particular oil-rich region. So the future mineral needs can be obtained from the continental shelves. So we can see the width of continental shelves. We have the Chilean coast, where it is occupied by trenches because of the convergent boundary, and here the continental shelf is almost absent, whereas we have Grand Banks region, which is one of the richest fishing grounds on Earth, and here we can see the Grand Banks region as a very wide continental shelf. And then the widest continental shelf occurs in the Siberian coast to the north of Russia. Here the continental shelf has a width of about 1000 kilometers. So if you have forgotten about various boundaries, we can see this is the divergent boundary, and we have convergent boundary. For example, here we have trenches where the oceanic plate is subducting below the continental plate. And then if there is the convergence between continents and oceans, we call it as ocean continent convergence. Like we have trenches which are formed near the Chilean coast, where the convergence is ocean continent convergence. On the other hand, we have convergence between the Japanese islands and the Pacific Ocean. Here the convergence is called as ocean-ocean convergence. So here again we have trenches. After continental shelves, we have continental slope, where the slope varies between 2 to 5 degrees, and it is quite deeper compared to the continental shelves. And then we have continental rise. Here the steepness falls, and it is quite comparable to the steepness of continental shelves. So it merges with the abyssal plain, which is deep sea plain, and the abyssal plain is filled with terrigenous deposits. Terrigenous deposits are nothing but the glacial and riverine deposits which are brought down by various water bodies. And here the depth varies between 3 to 6,000 kilometers, and in certain areas like the trench region, which is not a part of abyssal plain, the depth can be about 10 to 11 kilometers. So we have trenches. You can see this is one example for trench. This trench is called as Puerto Rico Trench near the Caribbean islands. So here trenches are narrow depressions. They are quite steep. For example, we have Mariana Trench, which is more than 11,000 meters deep. It is in the Pacific Ocean. So this particular region of trenches is a region of active volcanoes and very strong earthquakes. Here the earthquakes which are formed are called as deep focus earthquakes, and there are various types of earthquakes, being shallow focus and deep focus. Shallow focus earthquakes are less destructive, whereas the deep focus earthquakes are quite strong and very destructive. So most of the regions around trenches are hotbeds of earthquake activities. For example, we have Chilean coast and the Japanese coast, where we hear about frequent earthquakes. So these particular regions are the trenching regions are hotbeds of various tectonic forces, especially earthquakes and volcanoes. When it comes to trenches, the most number of trenches occur in the Pacific Ocean, followed by Atlantic, and Indian Ocean has least number of trenches. And the other important feature is mid-oceanic ridge. We have studied about mid-oceanic ridges, where we have divergent boundary. Here it is the volcanic vent, and there are mountain ranges on either side of the volcanic vent. These are parallel mountain ranges which are called as mid-oceanic ridges, and these are the longest mountain chains on Earth. And overall mid-oceanic ridges extend to a length of about 75,000 kilometers. And they are, along with the trenches, there are strong evidence in support of plate tectonics. We have studied these things in the previous videos. One important feature is Iceland, which is a part of mid-Atlantic ridge. So Iceland is the very significant island and the largest island that exists over the mid-oceanic ridges. So we have talked about abyssal plains, seamounts which do not reach the surface. So here we can see various abyssal hills. For example, we have volcanic islands, which are also example for abyssal hills, and then we have seamounts which doesn't reach the surface, and then we have guyards which have a flat top, and then we have submarine canyons. So we have talked about Hudson Canyon. So canyon is nothing but a deep gorge. So we need to know the difference between valley, gorge and canyon. Valley is usually V-shaped. So when it is V-shaped, the bottom portion is very less wide, whereas the upper portion is quite wider. Whereas when it comes to a ravine is also type of valley, but in ravine it is usually U-shaped, where the width at the lower surface is almost same as the width at the upper surface. And then we have gorge. Gorge is nothing but a bigger version of ravine. So we have gorges in the Himalayas like the Indus Gorge, etc. So all these gorges have U-shaped valleys, where we can see the widths in the top portion and the lower portion are almost equal, and the much bigger version of gorge is called as canyon. For example, we have Grand Canyon, which is a part of USA. So all these are examples for various important ocean relief features. So Hudson Canyon, which is a part of oceans, is one important canyon in the oceanic region. It is near New York City and the surrounding continental shelf. So largest canyons in oceans occur in the Bering Sea of Alaska. So Bering Sea is the sea between the Russian region and the Alaska state of USA. So other important oceanic features, the minor ones, are atoll. While studying about coral reefs, we'll study about fringing reef, barrier reef and atolls. So we'll study in detail later. Now let us look at bank and shoal. Banks are nothing but a flat plateau-like regions under the water surface, especially in the continental shelf regions. For example, we have Grand Banks and Dogger Bank, which is a part of North Sea. So all these are important banks, and banks are a very important fishing grounds. We have seen continental shelves are themselves a very good fishing grounds, with various factors like mixing of ocean waters, etc. being in their favor, whereas These flat banks have one good advantage is that they are quite shallow and support good nutrient rich water which is available at a very low depth. So they are productive fisheries of the world. Shoals are nothing but detached elevations and they are quite dangerous for navigation. Even reefs are quite shallow, as a result even they are very dangerous for navigation. So reefs are associated with coral reefs, various there are various reefs, namely fringing reef, barrier reef, etc. So we'll study them in detail. And the best example for reef is the Great Barrier Reef of Queensland coast of Australia, and they are also dangerous for navigation. So we'll study about the important concept of coral bleaching in the next videos. So coming to the significance of study of oceanic relief, as I've talked, oceans are a rich source of minerals, and in future they will become the primary source of minerals required for the mankind. Along with that, the movement of ocean water mainly depends on the relief of the ocean floor. So ocean relief gives us a basic understanding of motion of water, ocean currents, and various factors which are influenced by ocean currents. For example, we have fishing, where we have warm and cold waters meeting, and this meeting zone is a good fishing ground, and this particular type of meeting and movement of water is affected by the shape of ocean as well as various relief features. For example, we have Mediterranean Sea, where there is a sill between that blocks water at the lower levels between the Atlantic Ocean and the Mediterranean Sea. For example, sill is a narrow wall-like structure. On this side we have Mediterranean Sea. On this side we have Mediterranean Sea, and on this side we have Atlantic Sea. So the top 400 meters there is water exchange. As a result, the water at the top layers keeps moving from Atlantic to Mediterranean and reverse based on various conditions. And this particular sill stops the movement at the subsurface level, leading rise to various factors. We'll see that in the future videos. So ocean relief features also affect the movement of water. And we have seen how navigation and fishing are affected by various ocean relief features. So this is all about ocean relief features. In the next video we'll discuss other important concepts on oceanography.